This journey to learning more has no end. But where does it start? It starts right here on this pale blue dot. The Earth, a geoid, the third planet full of water, life, and potential. These orbits are of quite significance to us. The most significant one is the Leo orbit. Located within 2000 kilometers of the Earth's surface, its proximity enables low latency communication, high resolution imaging, and more. It houses the International Space Station, thousands of satellites for Earth observation, and major commercial internet constellations. So we get the fuel, the mine, the metal, and exceed the orbital velocity. Is that it? Well, we forgot a major factor: debris. Some are no larger than a bolt, tiny fragments moving at 28,000 kilometers per hour, fast enough to shatter metal. Project AETHER. It tries to understand this debris, their patterns, and explores ways on how our deployed satellites could be saved, be it maneuvers, forecasted collisions, and more. There are various things to account for and perform calculations. Due to perturbations, fuel remaining, comms off, Earth rotation, speed, maneuver type, action, success, impact, collision, deflection, safe. Our objective is to minimize the fuel and the time to make the most efficient decisions possible. Using Fast API, 3JS, and various Python libraries, we bring these functionalities and simulations with a live portal. This is Project AETHER. So yeah, hello everyone. Let's demonstrate Project AETHER. So I've used Fast API. So I've run this on Docker, and it's currently running on localhost. So going to localhost, I refresh this page. So yeah, that's localhost. That's that's the portal. So these controls on the top, these are actually controls. They will be changing the state of the environment in some way. So these are the satellite properties. So like I go here, it's going to be more detailed. These are the satellites, which satellites to choose from, and you can add more satellites as well. Timescope simulation, it is going to alter this entire universe. It is going to alter by a specific time. Compare satellites, you can compare the satellites as well. Collision, there could be two, right? Predictive collision and the immediate one. So autopilot, so if it sees a predictive collision, it is going to take an action directly without um, user approval needed. If it is off, it is going to ask for the user approval, and a user has the option to execute a manual maneuver as well in here. Or if the user doesn't respond, the autopilot will take over and perform anyway. All these details are constantly updating, as you can see. Yeah, there we go. And we have various satellites in here, and they're all in different high inclination and stuff like that. So right now, satellite 13 is connected to the mission control. Let's perform a maneuver, because you can only perform a maneuver that is in sight with the mission control. So I'm going to perform maneuver. So maneuver can be performed not only for collisions but for strategic reasons as well. So let's just make a very manual, very low maneuver, so that it doesn't violate the thrust and the safety conditions set. So I perform the maneuver. Maneuver executed successfully. I go here. It actually fails because somehow the thrust is actually exceeded. Yeah, yeah, okay. So I'm gonna try again. Since 13, yeah, somehow it exceeded. Let's make it very very tiny now. Let's make it 5 seconds, and I perform the maneuver executed successfully. Yeah, there we go. It's executed successfully. The remaining fuel is like this, and it's also from the rocket equation stuff. And I click this satellite. So this one's highlighted in the satellite emoji. Other satellites you can see are in a low opacity icon. So I go to 11. It is somewhere. It must be, yeah. There we go. 11th is right there. It's also connected in. So that. So create mission satellite, like I created Jarvis and stuff like that. So I'm gonna create another one. Let's say 1, 2, 3, 4, 5, 6. Initial altitude 656. Let's make it 1,000. Inclination, let's make it 10 degrees. Fuel, let's make it 80. Create, and now it's 53 right here. And yeah, it's connected. It's disconnected. So this log just goes on forever. Now coming to the main critical aspect. Uh, no matter how many debris we have, currently we have 20,000 debris against 53 mission satellites. So we ran various collision tests and stuff. So the chances of this happening are absolutely low, like absolutely low. So you can say zero. So that's the thing. I'm going to show some codes which I ran. So this one, collision detector.py. So it takes, you can say, 55 sats against this much debris. It runs this and again finds your potential collisions. So my point is, uh, at the moment, at the scale of this project, no matter how many debris we have against so and so satellites, we will not be able to demonstrate the collision because it is never going to happen. So right now, I'm working on a different concept called an aggressive debris. So then I plan to shoot out some aggressive debris at this satellite's path, and then uh, get these collision warnings in here and stuff like that. So that's the plan. But yeah, at the moment cannot demonstrate the collision because it is unlikely, like scientifically and mathematically impossible for this scale of the project. So that is all. And the autopilot, even if you turn it on and off, it won't hardly matter because the collision will not at all happen with this scenario. So that's the thing. And the only way to manifest or make a collision is to have that aggressive debris, which I'm working on at the moment. Yeah, so that's all. I thank you all for giving me an opportunity to work on such an interesting project.